Hello students, in our previous video we discussed about the loss of the photoelectric effect. Next one, the failures of the wave nature of the light to explain the photoelectric effect. To explain the photoelectric effect, that is the failures of the wave nature of the light. So now we are discussing that Einstein photoelectric equation. Einstein photoelectric equation. What is that Einstein photoelectric equation? Yes, Einstein postulated that light consists of the particles. Those particles we are calling the photons. According to the Einstein postulates, that is the light consists of the particles. Those are called as the photons. Those are called as the photons. The energy of the photon having the frequency nu. The energy of the photon having the frequency nu is E is equal to h nu. E is equal to h nu. This is the energy of the photon. Energy of the photon. According to him, if the radiation is incident on the photoelectric metal, each electron absorbs the one photon. Each electron absorbs the one photon, and that is come out from the metal surface and moving with certain velocity. Means that one have some kinetic energy. So in case if the photon have the frequency nu, that is incident on the photoelectric metal, then in that some energy is photon having the frequency nu, means energy is equal to how much? E is equal to h nu. In this energy, some part, a little part or maybe some part is utilized to remove the electron from the metal surface. We are calling that is the work function. Minimum amount of the energy required to remove the electron from the metal surface. So that is we are calling the work function. And the remaining energy is converted into the kinetic energy. Means total energy is equal to h nu. In that, some energy is utilized to remove the electron from the metal surface. This is nothing but the work function, and the remaining energy is converted into the kinetic energy. This is the kinetic energy maximum. Means electron is removed from the metal surface. Radiation having the frequency nu, that one have the energy h nu. That means photons having the frequency nu, means that one have the energy E is equal to h nu. So this radiation is incident on the metal surface. Then what happened? In that energy, that means h nu energy, some part is utilized to remove the electron from the metal surface. We are calling that is the work function. Work function in terms of the threshold frequency is equal to how much? That is nothing but the h nu naught. So energy E is equal to h nu. H nu is equal to, this is the h nu naught plus the kinetic energy, maximum kinetic energy. This is the Einstein photoelectric equation. For this one, different forms are also there. We are discussing that one also. H nu is equal to h nu naught plus half m into v square. That is nothing but the v max, maximum velocity. So means this is the maximum kinetic energy. So same expression we are representing in terms of that is the electron holes also. That is h nu is equal to h nu naught plus E into v naught. So already we learned that in case of the stopping potential, maximum kinetic energy is equal to the EV naught, maximum kinetic energy, EV naught. So h nu is equal to h nu naught plus E V naught. E V naught. Here V naught is the stopping potential. Nu naught is the threshold frequency. Nu is the frequency of the incident radiation or frequency of the photons. All these are according to the Einstein postulate. According to the Einstein postulate, the radiation consists of the particles. Those particles are called as the photons. Remember, those particles are called as the photons. The photons of the frequency nu having the energy E is equal to h nu. E is equal to h nu. Okay, right. So here, this is the Einstein photoelectric equation. By using this one, we are explaining the laws of the photoelectric effect. So that is the h nu is equal to h nu naught plus this one is nothing but the kinetic energy, maximum kinetic energy. Maximum kinetic energy. This is the Einstein photoelectric equation. By using this one, we are explaining this photoelectric equation. That one successfully explains the photoelectric effect or laws of the photoelectric effect. Perfect word. That is the laws of the photoelectric effect perfectly explained with the help of the photoelectric equation. This one successfully explains the laws of the photoelectric effect. So already we know that. First one is, in case of the laws of the photoelectric effect, frequency of the incident radiation is more than that of the threshold frequency. Then only photoelectric emission takes place. So means frequency of the radiation must and should more than that of the certain frequency. We are calling that is the threshold frequency. Next one, second one is, so frequency is depends upon the, kinetic energy depends upon the frequency. Kinetic energy depends upon the frequency. When frequency is more, kinetic energy is more. When frequency is low, kinetic energy is also low. Next, third one is, so this is the instantaneous process. Instantaneous process. When radiation is incident on the photoelectric metal, electron emission takes place. That is in the short interval of the time, that is nearly 10 to the power minus 9 seconds. So that's why we are calling that is the instantaneous process. And next one, fourth one is the electrons are continuously emitted. Electrons are continuously emitted. So in case of the wave nature of the light, that is the failure. In case of the wave nature of the light, when wavefront is incident on the photoelectric metal, bulk number of the electrons are emitted. But practically what happened? Electrons are continuously emitted. We are discussing that one also. Here that one is also successfully explained with the help of the Einstein photoelectric equation. Einstein photoelectric equation. So first try to observe from this expression, from the Einstein photoelectric equation, h nu minus h nu naught is equal to kinetic energy. That is nothing but the maximum kinetic energy. Maximum kinetic energy. So observe, kinetic energy is always positive. That is the half mv square. V is maybe negative also, but v square is positive. V square is positive. V may be negative also. Try to observe. V may be negative also, but V square is the positive. So here observe, this is positive. Kinetic energy is always positive. When kinetic energy is always positive, when frequency of the incident radiation is more than that of the threshold frequency, frequency of the incident radiation is more than that of the threshold frequency, then kinetic energy becomes positive. Kinetic energy always positive. But in this expression, from this expression, when that one is positive, when frequency of the incident radiation is more than that of the frequency, that is the threshold frequency, in that situation only kinetic energy becomes positive. Kinetic energy becomes positive. So means frequency of the incident radiation is more than that of the threshold frequency, then only photoelectric emission takes place. First one is explained with the help of the Einstein's photoelectric equation. Einstein's photoelectric equation. Second one. So that is nothing but the frequency is depends upon, kinetic energy depends upon the frequency. So observe the same expression. H into nu minus nu naught is equal to kinetic energy. Here observe H is the Planck constant, that is the constant. Here how these two are related. Nu minus nu naught is directly proportional to kinetic energy maximum kinetic energy. So means here these two are directly proportional to each other. Means when the frequency of the incident radiation is increases, then kinetic energy is also increases. Frequency of the incident radiation is increases. How these two are related? X is directly proportional to Y. If X value is increases, Y value is also increases. If X value is decreases, Y value is also decreases. So here kinetic energy and change in the frequency, these two are linearly related. So means nu minus nu naught is directly proportional to kinetic energy maximum. So that means when frequency is more, kinetic energy is also more. Frequency is increases, kinetic energy is also increases. Frequency is decreases, kinetic energy is also decreases. So in case if frequency value is below the threshold frequency, photoelectric emission does not take place. So second one is also successfully explained with the help of the Einstein's photoelectric equation. Next, third one. Yes, I am explaining the fourth one first. After that, we are going to the third one. Here, each electron that one absorbs the one photon. So means here intensity is increases. Intensity of the incident radiation is increases. Means in that situation what happened? Here intensity is increases, then current value is also increases. Photoelectric current value is also increases. So means here intensity increases means number of the photons are increases. Intensity increases means number of the photons in that radiation, that is increases. Number of the photons increases means number of the emitted electrons are increases. When number of the emitted electrons are increases, those are moving in external circuit, means that one constitute the current. So photoelectric current value is increases. So intensity is when intensity is increases, photoelectric current is increases. In case of the observations, experimental observations, we draw the graph like this. This is the intensity is taken on the x-axis, current value is taken on the y-axis. We get the graph, that is the straight line passing through the origin. Means here when this intensity is increases, photoelectric current is also increases. Here I am telling that one only. When intensity is increases means number of the photons are increases. According to Einstein, each electron that one absorbs the one photon. So means when intensity is increases means number of the photons are increases. The photons are increases. When number of the photons are increases, number of the electrons, emitted electrons are also increases. Means current value is increases. Okay. Next, this is the fourth one. Next, fifth one is the instantaneous process. Not third one. Instantaneous process. When radiation is incident on the photoelectric metal, each electron that one absorbs the one photon and that is come out from the metal surface within the fraction of the time. So means this is the instantaneous process. All these are successfully explained with the help of the Einstein photoelectric equation. Okay. So here try to observe one by one. Okay. So like this, that Einstein photoelectric equation successfully explains the photoelectric effect. Okay. So next one. Yes, next one. Observe here. H nu is equal to H nu naught plus half m, that is the kinetic energy maximum. In terms of the potential energy, H nu is equal to, this is we are writing in terms of the work function. Work function is denoted with the letter W naught or maybe phi naught. Work function is denoted with the letter W naught or maybe phi naught. So that is the H nu is equal to phi naught plus E into V naught. So if you take, this is the E V naught is equal to H nu minus phi naught. From this one, nu naught is equal to H by E into nu. V naught is equal to H by E into nu minus this one is the phi naught by E. If you observe, this equation is look like y is equal to mx minus c. Actually y is equal to mx plus c, but c is equal to how much? Minus phi naught by E. This is nothing but this. C is called as the y-intercept. So here slope is equal to how much? This is nothing but the slope. H by E is the slope. So for this, if you draw the graph, observe. So here for this one, if you draw the graph, here we are getting the graph like this. Take the frequency on the x-axis and stopping potential on the y-axis. We are getting the graph like this. Here this is the threshold frequency and y-intercept is equal to, this is the y-intercept, that value is equal to phi naught by E. Its value is equal to phi naught by E. Here this slope is equal to H by E. Slope of this line is equal to H by E. Okay. So y is equal to mx plus c. This equation is also look like y is equal to mx plus c. Here m means slope. Slope is equal to how much? H by E. Y-intercept is equal to how much? Phi naught by E. But that is in the negative y-axis direction. Actually, here Millikan observed so many experimental observations. From that one, Millikan conclude that is the photoelectric equation, no doubt. But the conclusion for these materials, for the different materials, not for this material, for different materials, this slope is the same. For different materials, that slope is same. So that is experimentally proven by the Mr. Millikan. Okay. So this is about the Einstein photoelectric equation. That is regarding the Einstein photoelectric equation. Next one is the particle nature of the light. That is the photons. So first of all, who proposed this particle nature of the light? In 1905, Mr. Albert Einstein proposed the particle nature of the light. Einstein proposed the particle nature of the light. According to the Einstein, the energy means that radiation, electromagnetic radiation, that when not continuously emitted as a wave, that is not continuously emitted as a wave. Instead of that is emitted like a packets of energy. These packets we are calling the photons. Here each photon is moving with the speed of light. That photons are moving with the speed of light. Speed of light means 3 into 10 to the power 8 meter per second. 3 into 10 to the power 8 meter per second. So this is according to the Albert Einstein. Okay. So observe here, when those photons are moving with certain velocity, they have the mass, that is nothing but the momentum. They have the momentum. They have the momentum and energy. They have the momentum and energy. They have the momentum and energy. So photons have some momentum and energy. So those are moving with the speed of the light. Those are moving with the speed of light. Okay. So here from that one, what is the conclusion? So observe here, characteristics of the photons. Characteristics of the photons. So here first one, photons are electrically neutral. Photons are electrically neutral. So means those are not deflected in electric and magnetic fields. Those are not deflected in electric and magnetic fields. So second one, the electromagnetic radiation means that is the light. The radiation when interact with the matter, those are, radiation when interact with the matter, that one behaves like a particle. So those are called as the photons. These photons are moving with the speed of the light. Those are moving with the speed of the light. That is the 3 into 10 to the power 8 meter per second. Those photons are moving with the speed of the light. Next one. So here the energy of the each photon E is equal to h nu. Energy of the photon having the frequency nu. That is the E is equal to h nu. That is nothing but the hc by lambda. So observe C is equal to nu lambda. Frequency into wavelength, that is nothing but this speed. So from here onwards, nu is equal to C by lambda, hc by lambda. So energy is equal to hc by lambda. Next one, so here one electron is absorbs the one photon. In that situation, total energy is absorbed by that electron. Means when radiation is incident on the photoelectric metal surface, each electron absorbs the one photon. In that situation, so total energy is absorbed by that electron, and that one is come out from the metal surface. So here one photon is absorbed by one electron. One photon is absorbed by the one electron. Next one is here is for the photons, mass is exist due to its kinetic energy only. Why? Because rest mass of the photons is equal to 0. Therefore, mass is exist due to its kinetic energy only. That means its energy only. So if you observe, mass of the photon is equal to m. Those are moving with the speed c. Then energy is equal to mc square according to the Einstein mass energy relation. So we know that energy of the photon is equal to h nu. H nu is equal to mc square. From this one, m is equal to h nu by c square. So therefore mass of the photon, from this one, mass of the photon is equal to h nu by c square. So mass of the photon is exist when those photons are in the motion. Rest mass of the photon is equal to 0. This is the mass of the photon. So here mass of the photon is exist due to its energy only. Next Next one, momentum of the photon is equal to how much? Momentum P is equal to m into C. Actually m into V, m mass of the particle. If it is moving with the speed V, then momentum is equal to mass into velocity, or maybe mass into m into V, sorry, m into V. But here that photons are moving with the speed of the light, therefore P is equal to mc. P is equal to mc, but m is equal to how much? This is the h nu by c square into c. Cancel, that is equal to h nu by c. But nu by c is equal to how much? Energy E is equal to h nu. From this one, yes, sorry, no need this one. C is equal to nu lambda. From this one, nu by c is equal to 1 by lambda. Nu by c is equal to 1 by lambda. Therefore, P, momentum P is equal to h by lambda. Momentum P is equal to h by lambda. Yes, sorry. Momentum P is equal to, this is the h by lambda. So these are the conclusions. In case there is the conclusions or maybe characteristics of the photons. First one, observe, photons are electrically neutral. That one does not deviate from its original path in case of the electric and magnetic fields. Second one is, when radiation is interact with the matter, in that situation, that radiation behaves like a particle. Those particles we are calling the photons. So those photons are moving with the speed of the light, 3 into 10 to the power 8 meter per second. Next, energy of the photon is equal. Actually, photons consist of the energy and momentum. So energy is equal to how much? Energy is equal to hc by lambda. That is nothing but the h nu, but c is equal to nu into lambda. Therefore, nu is equal to c by lambda. Next one electron absorbs the one photon. When radiation is incident on the photoelectric metal, each electron absorbs the one photon. So in that situation, total energy contained by the photon is gained by that electron. Means energy remains constant. Energy conserved. Energy remains constant. Energy conserved. So next, mass is exist. For the photon, mass is exist due to its kinetic energy. Kinetic energy. So from that one, mass m is equal to h nu by c square. Next one, momentum of the photon is equal to h by lambda. H by lambda. These are the conclusions. Okay, these are the conclusions. Next one, rest mass of the photon. Here you remember this one also. Rest mass of the photon is equal to 0. Means m naught is equal to 0. Rest mass is equal to 0. Okay. So, yes. For the next concept, next one, that is the de Broglie hypothesis. So for that one we will discuss in the next video. Okay, all of you, bye.